Hello, everyone. I'm Fyodor Lyakov, and today we are going to talk about major redirection and then our new project Melange for optimizing major stream processing for virtual desktop infrastructures. So it is kind of in the middle of different technologies for virtualization and major processing, and also remote computing of different kinds. So a few words about us. So we have just started this project. It is really new. Currently, there is a team of 3 developers. One of them is me. Another one is Igor. He will be helping me today. Also, Alexei, he's not here. So the project is hosted at GitHub. You can see it. And currently, the work is sponsored by a Russian company, Mira. So probably you have never heard about that company, but a few words, just a few words. So this is a Russian software R&D services company, quite big, as you can see. And so it is providing services for various companies all over the world. So if any questions, you can ask me. Okay. So we will be talking about major processing in virtual desktop environments and how to optimize them. So first of all, we want to show we want to identify what we are talking about. So use cases for major processing. First of all, it is a creating and playing of local media content. And the second kind of use case is remote media content, like user playing a video from YouTube. The next one is telecommunications. It is really important and fairly different from the others. So we will be focusing on the last two. The first one is covered by different technologies, actually. I can mention them later, but we will be focusing on the remote media playback and telecommunications. Okay. Then I want to give you a short overview of the Red Hat Spice. We will be talking about Red Hat Spice because it is the most prominent open source remote virtual desktop virtual display solution, I would say. Other virtual displays like VNC and probably NX, they also probably can be covered, but I will be just talking about Spice today. So this is how Spice is working. The system is based on hypervisor Linux KVM. The virtual machine is running QEMU. Spice server is running inside, so in the red, the Spice components are shown. Spice server is running inside the context of the virtual machine and exposes itself to the Spice client, which is connected with a Spice protocol. So also there is a Spice agent as a guest, and some virtual drivers involved, like QXL, for enhanced video drivers. So let's look how the playback of remote media happens in the VDI and what problems we can see here. So here we see the virtual machine and the simple media player installed there with the media engine component highlighted in red. So when user wants to play YouTube on his virtual machine, it connects, probably via HTTP. The player connects, and the media is played locally by that player and decoded into the virtual devices and drivers. They then handle it and get it to the Spice server, which then encodes it once again. This happens at the host. And the media then transferred over a Spice channel to the Spice client, and then once again decoded and played out. So we see that is not very efficient. Next one, it is even worse. It is a VoIP system and a VDI. So if we just install a soft phone as a virtual machine, and have some VoIP system like SIP, proxy, or whatever, then we can see that media is not traveling peer-to-peer anymore. It is traveling to media engine, the virtual machine, and then again is transcoded. And the same media path is from the opposite direction from the microphone of the client, and then it is going into the opposite direction. It is also non-optimal. So we can highlight current following problem here. So it is sometimes called higher pinning effect. So media streams are passing through the virtualization server, not peer-to-peer. And also the streams are transcoded at the server. Transcoded, it can be allowed to just increases the CPU load and decreases the VM density of this virtualization server, but the main part is that streams are passing through the virtualization server, so increases the network load, and most worst effect is increased latency, jitter, maybe packet loss if the networks are unreliable. So if, for example, the virtualization server, the client, and the far end all are located in different places, few hundred of kilometers away of each other, this becomes very ineffective, and for example, VoIP solutions stop working. Okay, so how this situation is addressed actually? So this is a well-known problem for at least VoIP guys, and there are custom solutions. Most of them, as I am aware of, they are proprietary solutions. I do not want to name them here. It doesn't really matter. So this is a generic scheme of such solution by VoIP vendors. So they introduce two soft phones. One at the client side, another one at the guest. So the guest one, it is shown to the user and provides user interface. The client one is actually handling all the signaling and the media. And they are keeping both soft phones are kept synchronized via some kind of CTI, computer telephone interface, and so that is usually a proprietary system, and it is very custom. It is not general, and that's why we want to introduce something different. That is a media redirection concept. So as you can see here, this is displayed for the VoIP case, but for audio media player it is the same. So as you can see here, we introduce media engine stubs for the soft phone, and this media engine stubs implement that API, but not the actual media engine, but using it some kind of RPC client, which is then sends this control information to the RPC service located at the client. The data is sent via virtual channel inside the SPICE protocol. For this case, or if it is not SPICE, something else can be used. So, and the actual media engine is located at the client. It is then controlled by the RPC service, and the media path is peer-to-peer again. So this is a solution we propose for this problems. And a few words about video here. So video is more complicated than audio because we need to display the video on top of the virtual screen of the SPICE client in this case. So for this case, we need some kind of overlay renderer API in the client. It is one kind of solution. Probably there are different ways to embed the output of the local video into this virtual screen. So this scheme shows how it can be done in general. So So what is done now? That was only a concept, but now we want to show you that what we have done so far. Basically, we have two proof of concepts for this. First one, called prototype A. It is a audio player. And basically, audio player from GStreamer examples, basically a hello world from GStreamer. If you are familiar with GStreamer, you probably know that there is high-level play-bin API, something like that. So this API creates a play-bin and attach a message handler for the bus of that play-bin, and also set properties of that play-bin like URI. That was implemented in the GStreamer stubs library, prototype library, which is then converts these calls to dbus calls. So at the server side, the client side, we are using now the regeruns GSTD. This is a simple, fairly simple GStreamer dbus daemon. It is fairly old, written in the wall actually. It is old and that currently doesn't support the latest GStreamer. It is only 0.10 GStreamer, so we need to port it to a new one, probably. But for now, it works still. There's high-level APIs in the dbus daemon we use to implement that behavior. So effectively, what we have an audio player which can be built from the same source. It can be linked whether with a local GStreamer library or with the GStreamer stubs and work in this environment as it is shown there. So dbus is used here for RPC. It is a really controversial, I would say, and there are multiple concerns about dbus, but multiple pro and contra against it. So for now, it is not a production level. So integration with Spice, it hasn't been implemented yet. So we are using simple TCP circuit. So at the guest, we create the session dbus bus via TCP, not via Unix sockets, and connect the local service to it. And we will show that in the demo. Another prototype, B, it is a soft phone. It is not a full-featured soft phone. It is a demo-only soft phone, which doesn't actually do any signaling. It is very simple RTP streaming soft phone. And it is a bug here. It is not using GStreamer at all. It is based on Google WebRTC internal, low-level, fairly low-level media engine APIs. If you are familiar with them, they are fairly good for implementing soft phones, actually. So that soft phone is kind of similar to that audio player. It works just the same. It can be linked locally with from the same source, and can be built and linked with local Google WebRTC media engine, or can be linked with the stubs, which are implemented. In this case, they are implemented using Apache Thrift RPC system. It is another way. Instead of dbus, we can use the Thrift, and it has some good sides, like being independent of all this dbus desktop things happening now. So we can control this infrastructure for our use cases. But it lacks features, like it doesn't have signals, it doesn't have actually services in this sort of, it doesn't have kind of a bus or whatever. So it is limited. But it is really good for the proof of concept, because it is capable of generating all the glue code, and we just need to give it a file describing our services, and we get the whole RPC stack back and use it, just implement the calls. So I'm going to show you how it works. Probably it can be not so very interesting, but Igor is going to help me with this. So we are going to show you how this soft phone works. So here, I need to show you. There is a virtual machine. Okay. So as a local machine, I start that service. So I started the, so basically what we have, at one PC we have basically it plays a role of a client and the host, because we do not have much equipment here. And so at it there is a virtual machine running. And I'm going to start. I'm going to start a remote version of that soft phone. It has very simple test UI, but what we can see here, it is capable of selecting clients audio devices. Don't have much of them today. So it is capable of playing, for example, playing a testing a microphone. For example, it doesn't work. Yeah, I have a microphone muted because for the next stuff I would like. So yeah, the test works also, and it is actually working via that Thrift RPC system. It is not. It doesn't have any media locally, so we can even start. For example, sorry, GNOME. You can start the GNOME system monitor and to see the network usage. So you see that is 0, basically. So if we now want to make a call. Sorry. So to make a call, we need to enter the IP pointer is not seen there for some reason. Okay. So we have a local wired network here between two laptops. One is here. So yeah, it works, and you can see that there is no, sorry. So the streaming is continuous, but that just audio is muted. But if you look here, it is a very low network usage actually. It is not that audio streaming. It is actually something different happening here. So that audio stream is G711. It is about 10 kilobytes per second, actually. So if we open the local, the client, we can actually see that network usage is here about 12 kilobytes per second. So that is how this works, and basically the same thing works for audio player. I don't think I need to show it. All this code is available in the GitHub repository. You can check it out. Thank you, Igor. So I will continue with okay, so about our now next steps. So currently we have two demo-only applications, and we are going to integrate them with Spice. This is the next major step. And also, the next step would be integrating with some real-world audio player, GStreamer-based, and then some real-world soft phone. For example, probably we will go with telepathy framework and soft phones based on it. It is already dbus driven, so probably we would not need to do all this stuff with our own, without implementing any stubs, probably. Also, there is the possibility to explore the WebRTC in the browsers. So it is really kind of dark matter here. And also, of course, we need to work on the video part. It is harder because it's video overlay. It is the next step. And also, currently we are focusing on Linux to Linux communications in this case, but it is feasible to add Android for clients and Windows for clients and guests. Okay, so there are kind of questions, architecture questions I would like to raise, because we haven't decided on them yet, and so any input would be welcome, and any comments about this. So we have not decided on the RPC system. So do we need to use dbus in this case, or do we need Thrift? Or maybe we can go with both, but it is expensive. We are small and we are working as volunteers now, just slightly sponsored. So another question is what backends to support. We start with GStreamer, but there are others like VLC. Probably need to look into it as well. I don't have any experience with it. Not sure whether it maps into this. So for GStreamer, it actually maps file level, because at the high-level API, the actual implementation of the pipelines and so on happens at the client side, and controlling that GStreamer via dbus works fine, not generate much traffic. Another topic to discuss, it is the Spice API for additional virtual channels. So basically, Spice allows adding new channels, but need to identify what channels do we need and what interfaces. At Ghost operating system, we see that we need a shared library, but at the client side, it is not clear yet. And also, overlay ranging API, it is another open topic. Another huge topic, it is fault tolerance, and so handling of the disconnects and crashes. It is all needs to be handled somehow. Currently, if we go with dbus, we can have a service stub as the guest, which would take over the real client-side service in case of disconnect, and then media application will use that stub instead. So probably it is the way to go, at least if we go with dbus. And also a couple of other questions like crash recovery. If the media engine crashes, we probably need to keep it in separate process. But then how we can organize the rendering of the video into the window of another process? It is also a good question. So I want to conclude what we have done so far. So there is a problem in the VDI with the media processing, and there are various solutions, but they are not ideal. And what we want, we have introduced the concept how to redirect media in using that open source components already available. And 2 prototypes we have shown only one, but the other one is also working. I can show it if you are interested. So that's all. Questions? Okay. If any questions, we can talk outside, of course.